The latest in commercial space and designing sweaty spacecraft. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. From the inaugural launch of Blue Origin's New Glenn rocket to plans for SpaceX's Starship to lift off once again, it's been a busy year for commercial space. We'll speak with the host of the podcast Main Engine Cutoff, Anthony Colangelo, about commercial space news and what's ahead in 2025. Then, how do you protect a spacecraft that's coming back to Earth from the heat of re-entry? One engineer says you make it sweat. We'll speak with Texas A&M's Hassani Ifti about his research on a new way to protect spacecraft from the heat of re-entry. That's ahead on Are We There Yet? Players in the commercial space industry have become crucial for the advancement of space exploration. Private companies are working on giant new vehicles, like SpaceX's Starship and Blue Origin's New Glenn rocket, that will aid in missions to the Moon and Mars within the next several years. Plus, commercial space companies will also establish commercial space stations once the ISS retires in 2030. So how are these missions faring now? And do potential budget cuts to NASA impact the role of private space exploration companies? Here to answer those questions and give us a commercial space news roundup is Anthony Colangelo. He's the host of the podcast Main Engine Cutoff and the co-host of the podcast Off Nominal. Anthony, welcome back to the show.
Hey man, thanks so much for having me back.
Let's talk about one of the milestone commercial launches this year, the launch of New Glenn. Successful launch, aside from not recovering the booster. What do we know about next steps for Blue Origin's mega rocket?
I mean, there's some reports that the launch is coming up at the end of May. That was the last date I saw circulated. A lot of doubt that was going to actually happen. They have really not said a lot in terms of when it's going to land specifically, or land on the schedule. Whether or not it will land is up for debate. They've been doing some tests following that first launch. They had an issue, like you mentioned, on landing. They didn't get those engines to relight on the way back in to recover the booster, and that I think that still made it a lot farther than anyone else would have guessed. Making it to orbit successfully on the first launch is something that I don't think has ever happened to that point on a commercial vehicle in this regard, especially one as big as this with really no, run up, right? Of course, Falcon Heavy made it to orbit, but they had all that practice with Falcon 9. Blue Origin didn't really have the same situation going on when they went from New Shepard all the way up to New Glenn. So very impressive. The first stage recovery has something that historically, they had talked about wanting to nail it from the first launch. No one really thought that was a reasonable expectation. So this went as expected. Whether or not they can get those engines to relight on the second launch is going to be the milestone to watch for. So when you're watching that launch, see if they're able to relight, get any telemetry back from the first stage. I think people realize, if you look at some graphics of how big New Glenn's first stage is compared to Saturn V, it's not too far off, from first stages. So
what do we know about this second launch? Do they have a payload? Have they announced a payload? What is it? What's it flinging into space?
They still have not stated specifically. Historically, they were talking about being able to launch a mission to Mars for NASA. That's still in the cards, though. That sounded like that was going to land later in the year if they're able to get it off this year. They're very mysterious. Blue Origin gives you nothing. So, I don't know. Try to predict what it's going to be. They've also haven't announced a lot of publicly available payloads, right? They have a huge contract with Amazon for a bunch of launches. They've got this NASA Mars mission. There's talk of at some point, not necessarily the next mission, but at some point having a Blue Moon demonstration launch, whether that is something that would actually go down to the lunar surface or at least just kind of be shaped like Blue Moon, their lander that is meant for lunar purposes. So there's chances that they would fly something like that. But, in terms of the actual pipeline of missions for New Glenn, we're not going to get any info out. We hear about their astronauts that are launching New Shepard like 2 days before this thing goes off. There's nothing not cool that they could launch next.
Yeah, and it's a super mega rocket, so it's always fun to watch.
Yeah, it's absolutely monster.
Speaking of monster rockets, what's new with SpaceX's Starship? It's rumored to fly later this month. What do we know about this?
Yeah, they're working on the ship and the booster for the next launch. Really taking their time with this one. They've got to get this right. They've had a series of failures with the Starship upper stage related to the engine, the Raptor engines. And, they made some tweaks last time, thought they fixed the issue. Turns out, they had a similar, not exactly the same issue, but similar issue enough that it caused major concern. And at a time when there's major scrutiny around SpaceX, Elon Musk, all things Starship, making sure that you get this next one right and you don't have yet another video of debris raining across the Caribbean and southern parts of Florida is really important. Whether or not that was particularly impactful to people on the ground is kind of beside the point. It's more of an optics thing at that point. You don't want to create massive meteor showers with your rocket time and time again. You want to show that you're operating this thing reliably. And certainly for their own purposes, they kind of are stuck at this gate in their roadmap where they need to make orbit with this vehicle. They need to show they can deploy payloads from it. They need to get to the point, most importantly, that they can start testing out orbital refilling. That is something that they've said was on the roadmap for 2025. We are halfway through. They haven't even made orbit yet. I don't think it's alarmist to say there's major problems in Starship land right now because they got to get more on track for making it to orbit, doing these orbital refilling tests, because that unlocks the rest of the roadmap for Starship. It's a tough roadmap for them, right? Nobody doubts that SpaceX can pull something of this complexity off, but to get to that point, you got to fly a ton of missions. You got to have them work reliably. They've got to meet up in orbit. They've got to transfer propellant at a scale that no one has ever done. So from here to there is a pretty staggering amount of technical achievement. I am confident the team will figure it out, but making sure the next step is successful is important because of the environment they're operating in.
Starship is integral to the first Artemis moon lander. That's an uncertain future for that program, which we may get into later today. But I mean, this is necessary to return astronauts to the lunar surface. Was the expectation that SpaceX would be farther along in development by now?
Certainly. I mean, there's no way to really slice up their schedule and say that they are ahead of where you thought they would be, or even obviously SpaceX projections historically have been over optimistic, and you can criticize that. You can say it's a good thing, right? They try to bite off a lot. They give themselves aggressive deadlines, and that means that they create things that happen a lot sooner than everyone else does in the industry. Certainly, when you look at their calendar, they are a couple of launches behind at this point. The fact that, we're coming up on the 9th flight here and they haven't made orbit yet. And like I said, some of the stuff that they need to prove out, orbital refilling being the number one, but payload deployments as well. Starlink itself, the main money driver for SpaceX right now, its future is dependent on being able to launch really large satellites with Starship. And right now, they're still launching on Falcon 9, which limits their technical capability, which in the end will limit the amount of customers they can sign up and serve with the Starlink constellation. So it is kind of a twisted knot of demands from SpaceX. They want to be flying so they can be more profitable with Starlink so that they can invest in Starship and continue their roadmap. And then they have the competing demand, like you said, of contributing to the Artemis mission and needing to fly a lot of Starships to refill a lunar lander that will go fly astronauts to the lunar surface for the first time in more than 50 years. There's political winds shifting on the Artemis department. There are financial considerations on the Starlink side that at some point in the long future of the company will threaten the company's viability if they're not able to get that amount of revenue turned on in the way that they need out of Starlink.
Let's talk about another company that's running into some engineering challenges, Firefly Aerospace. What's going on with them?
They've had, 6 launches right now. Only 2 have gone fully successfully. They've had a mix of issues. Most recently, at stage separation of their first stage, something happened. We think the first stage did blow up and maybe damage the second stage, but when they cut to the engine camera on the second stage, there was just no engine bell. So this thing was thrusting without an engine bell, which, meant it was doing something, but it didn't do enough to make orbit. It was one of the more chaotic launch failures I've seen. They had a lunar lander not too long ago land successfully on the moon, the first commercial lander to land fully successfully on the lunar surface, and a major achievement. Without that, I'm not sure the kind of look that we'd give to Firefly with a string of failures and a very spotty reputation here with Alpha. Not great, especially as they're working on a bigger and better launch vehicle in partnership with Northrop Grumman. That's a launch vehicle that would be able to lift a lot more mass to orbit than their Alpha launch vehicle does. It will basically replace the Antares vehicle that flew a couple of years ago to take Cygnus to the space station, roughly in line with that with a couple of good enhancements. I always thought it was interesting because of their partnership with Northrop Grumman. They seem to be leaning into that kind of like big aerospace prime direction. There's obviously a lot more business to be had there than there is in a small satellite market. So they were intending to head in that direction. But if they've got such a spotty reputation with the launch vehicle, let's look how that worked out for Virgin Orbit and Astra and some of the others that we've seen come before them.
It is 2025, which means we are 5 years away from the planned retirement of the International Space Station. Where are we at in the development of some of these commercial stations?
I don't know if I'm going to get better than that noise I just made. We've got, VAST seems to be one that has my hopes up. They are not involved in any of the NASA programs so far. They are really operating in a SpaceX-like mentality, leaning into, cheap hardware, iterative development, and testing things as you fly. It seems likely that in the next year or 2 years, they're going to put something up that's a viable space station. The others are kind of in this weird mix. Axiom Space has had financial problems in the last couple of years. They've just changed out their CEO. They lose money on these private astronaut flights they do to the ISS, and their hardware is a year or two behind schedule in terms of getting a module up to the ISS. On the other side, you've got, a congressional funding question about commercial space stations, and that NASA hasn't really went that hard on the commercial space station portion of their budget over the last few years. And now we're seeing the budgetary problems generally, that they're looking at a huge cut year over year. Does that mean that's going to get more money for the commercial space stations? Probably not. To me, there's just never been enough money from the NASA side to really show that they're strongly committed. And that's a tough chicken or the egg. Are these companies going to build a space station for a market that they don't really know exists yet and depends on NASA being an anchor customer, while at the same time, NASA's not really funding themselves to be an anchor customer? I don't really know how this is going to work out in the kind of intended approach, but something like VAST that's operating outside of this environment, has some funding behind themselves, try to keep these costs of the actual space station on the lower end. That seems more viable to me. Whether or not there's a customer there to buy it is really the big question for the next 5 years to sort out.
All eyes are on the Trump administration, their budget proposals, the direction of where NASA is going. But on your podcast, Main Engine Cutoff, earlier this month, you had Mark Albrecht on. He was on the Trump 2024 transition team. What did you glean from him during that interview about what the Trump administration is prioritizing and maybe some of the foundational decisions as to where they're going when it comes to this agency?
Yeah, the NASA side is kind of murky, to be honest. There's huge cuts across the board in government. So when you try to stack up, I try not to compare the NASA cuts to NASA's budget last year, but to the cuts elsewhere in government and see how is this really shaking out on a relative basis. Space has always been funny that it's not really exactly partisan. So, talking with Mark, getting a sense of what the inspiration was behind some of the initiatives. And honestly, I think national security is probably a bigger focus of this administration than civil space policy. But it sounded like, talking with him, he's not he's expecting the congressional pushback to be there for the NASA side and some of the parochial interests to really come out, and whether or not you can trim in some of the things that the Trump administration sees as the excesses, right? He's explicitly stated climate, DEI, things that you would expect for a Republican administration. That's really what I wanted to get a sense for, was is there unexpected stuff here? Because I think we all went into Trump 2.0 with an idea on what we would see, and emphasis on human spaceflight over science, or earth science especially, or education. A lot of the run-of-the-mill Republican stuff, to be honest. Where they're at on the national security side is really interesting. There's been a huge emphasis on this Golden Dome program. The space side of the Golden Dome program is about one old NASA budget per year, $25 billion on this initial lift of the Golden Dome. So that has huge opportunity for launch providers, for a lot of the small launch players that are looking at hypersonics research, satellite providers like SpaceX for missile defense payloads and tracking. There's a huge space opportunity there. And I'm wondering if, the emphasis on that is going to draw some of the people away from interested on the civil science space side of things over to the national security side, given that you've got to follow what the market demands are. And, human spaceflight is great, but if there's a massive increase on the national security space side, you're probably going to be drawn, if you're the person looking at the books on some of these space companies, you're going to be drawn more towards that end of the spectrum than, a cool Venus mission.
And as you mentioned, Mark posted on X, it will be a golden era of U.S. space exploration, innovation, and security, with America First as its guiding light. So you can really see some of those things being played out throughout the policies that are being enacted, right, Anthony?
Yeah, and the people that they pick are really interesting, right? There's the Jared Isaacmans, there's Troy Mink over at the Secretary of the Air Force. There's people that aren't in that partisan game, aren't in that real MAGA wing, but are more of commercial space thinkers. Seeing how that will come up against, Jared Isaacman tried to save the Hubble Space Telescope himself. Seeing that come up against let's cancel the next great space telescope is going to be a really interesting 2025. Seeing what the congressional pushback on is, from senators in Alabama or senators in Maryland or senators from Texas and Seattle kind of teaming up and going against some of these proposed cuts it just makes for really interesting battle lines. And at the end of the day, is that the fight that the Trump administration's, is that the hill they're going to die on when they're trying to get all these other things done that they prioritize more? Probably not. But at some point, the budget request has to happen. At some point, the conversation needs to start. Getting a sense for that is why I have people like Mark on the show, because I feel like, we don't often hear a lot about the transition team once January 20th hits, but it is a lot of that guiding light that you see the first 100 days. They kind of go in a certain direction that was, the transition team was leaning into.
Give it a listen. It's the latest episode of the podcast Main Engine Cutoff. I've been speaking with host Anthony Colangelo. Anthony, thank you so much for joining us.
Thanks, Brendan.
Still to come, we all sweat, even spacecraft.
Just like when we sweat, we have a layer of sweat on us. So if the spacecraft is sweating a gas, then it would have a layer of gas on it. And that layer of gas would keep the heat from the hot gas away as it re-enters the Earth's atmosphere.
A glimpse at how engineers are working to protect vehicles coming back to our planet. That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. After launching a vehicle into space, how do engineers protect it when it's coming back to our planet? Well, during re-entry, a spacecraft is exposed to high speeds and friction, which makes the shield on the vehicle extremely hot. Once back on solid ground, it can take quite some time to repair a spacecraft and ready it for the next flight. But Hassani Ifti, an assistant professor at Texas A&M University, is hoping to change the way we shield vehicles from the harmful effects of re-entry with another way to shield a spacecraft, using gas. And with this gas, it would look like the spacecraft is sweating. Our producer, Marion Summerall, spoke with Ifti about his research on the gaseous heat shield. Here's part of that conversation now.
Hassan, welcome to the show.
Thanks for having me, Marianne.
We're talking about something that I think is fascinating. It's a spacecraft that sweats. We're talking about some research that you've been doing that makes a spacecraft look like it's sweating. So let's talk about why this is needed and some of the technology that you've been working on.
So first of all, this is very exciting, and this has been my life's work for about 9 years now. So
Wow.
So why do we need something like this? Why do we even care about a sweaty rocket? So let's think about what a rocket would do. So we'd send a rocket out in outer space. It will go for a certain mission and come back again. So it's the coming home part that really is the focus of this technology. So when we have a rocket re-entering the Earth's atmosphere, it's coming in at about 17,500 miles per hour. So it's pretty fast. So if you think about rubbing your hands together, right, it generates heat. So you can imagine if you're coming this fast into the Earth's atmosphere, and all of a sudden you will be hit by this atmosphere, which is air for Earth, you would have friction, right? Just like when we rub our hands, and that friction would generate heat. So all of that kinetic energy that you have when you're coming back home is being converted into heat, mostly because it's being stopped at the skin of the spacecraft in this case. So this generates a lot of heating, and the gas around your vehicle, your spacecraft, would be about a little above 10,000 degrees Celsius. And then that heat can go into and will go into your vehicle.
That's why sometimes I'm guessing, right, that it takes so long to maybe repair some of these spacecraft. Once they come back down, they need to evaluate them before they can fly again. And that's even if they can, right?
Exactly. So that's the problem. So all of this heat means that we have to have a heat shield to protect our vehicle. The state of the art is having predominantly two kinds of heat shields. So you would have an ablative heat shield. As the spacecraft comes into the atmosphere, it heats up and it starts to melt away. So that's the ablator. So this is in a very simplistic way you could think of it, that it loses itself as it comes into the atmosphere and thereby protects the vehicle. And the other kind, you have something, the kind that the space shuttle had was these tiles. So they would heat up and radiate out the heat back to space. So the problem, as you said correctly, is that once we are back, if you have an ablator, you would have to replace the whole heat shield if you wanted to reuse that vehicle. And if you have these tiles, you'd have to carefully go through these tiles, these thousands of tiles on a vehicle, and find the ones that were damaged during re-entry and refurbish them, which takes a long time. So it's a high cost, of course. It takes a long time, say anywhere between 3 to 6 months, and it's intense labor as well. The takeaway here is that today's technology is not fully reusable, and the emphasis here is really the part on fully reusable, right? Just like our aircraft are fully reusable. If I take a Boeing 777, for example, I go to my destination, 90-minute turnaround, and I can use it again. So that's essentially the dream for this technology.
A rocket could act as an airplane, right? Go to space, come back, and then guess what? It's going again. Just like a plane.
Exactly. Yes. Wouldn't that be great? Then, and that would also bring the travel of space travel costs down. So if you think about today, if you buy a new car, you're not just going to use it once. If an airline buys a new aircraft, they're not just going to go from, say, New York to London once and then throw it away. But that's what we're doing with our spacecraft today. If you go to Mars and come back again, you're using the same vehicle Think about that feature. That's pretty exciting to me.
Fascinating to think about the possibilities behind this. Now, I want to get into something. It would appear with this technology and this research you're doing that the spacecraft would look like it's sweating. Let's talk about it. Why would it look like it's sweating, and how is the research you're doing better than some of the technology we talked about that are on other space vehicles, such as like the space shuttle you mentioned?
First of all, I'd say that the current technology we have, they're actually great at what they do. With this technology, the sweating rocket, or say, what we in the academic world say, transpiration cooling, it will actually help us increase the degree of reusability of a vehicle. So it will actually augment the technology that we have for heat shields today and make them more reusable. So we would probably use it in combination with the current technology. As I said, the current heat shields, they get damaged as they are being used in re-entry. So think about a heat shield that's gaseous. So if you were to have a blanket of gas around your vehicle, and if that gas were to keep the heat away, so why would that happen? Gases generally have a very low thermal conductivity. So gases are really good thermal insulators. They keep heat away. So think about your puffer jacket, for example. In the winter, you're wearing a puffer jacket. It keeps you warm. And the reason for it is the puffer jacket actually has lots of air in it.
Huh.
So you kind of have a layer of air on top of you, which is stopping the heat from your body from going away to the atmosphere. So it's sort of trapping the heat. So if you now take that same idea and say, okay, I want to have a blanket of gas around my vehicle, which would trap or stop the heat from coming into the vehicle. So the other way around, I want to stop that heat in the hot gas coming into my vehicle. So now you think about it, if I have a gaseous layer, it would start to mix away with the atmospheric gas. For example, if you take a cup of coffee and you drip some, say, drops of milk, it automatically starts to mix, right? So just like two liquids would mix, in physics we say gas and liquids, they're all fluids, right? So two gases together, say air and the gas you have as your protection, it would start to mix. So you would lose your protective layer. In order to prevent that, you would want to have a continuously, say, generating layer. And how would you do that? You would keep sweating it out of a porous skin on the vehicle. Just like we sweat today, if you go to the gym, you're going to sweat, of course. Think about your spacecraft sweating a gas such as nitrogen or helium or argon, then you have a layer of that gas. Just like when we sweat, we have a layer of sweat on us. So if the spacecraft is sweating a gas, then it would have a layer of gas on it. And that layer of gas would keep the heat from the hot gas away as it re-enters the Earth's atmosphere.
By having this spacecraft sweat, you can have it be more reusable, which then, from what you were saying, the goal is to have such reusability within these vehicles that we can be just overall faster in our trips to space. We can save money, time, effort. I mean, this is fascinating. Now, I want to ask, how do you test this? How are you testing this in your lab? How are you how are you doing this?
By the way, this idea has been there for a while now, and different groups at different times have attacked this with different techniques. Again, now we have a very exciting time for space. So that's, it gives us a chance to attack this problem again with new, say, technology. What we are doing at Texas A&M is, in collaboration with Canopy Aerospace, creating these 3D printed porous materials. So porous materials, they have lots of holes in them. Just like our skin does, we have lots of pores in our skin, right? With this new, say, skin of the vehicle, we want to inject a particular gas. Now, I'll come to the gas a bit later, but once we have this transpiration, so this sweating of the gas, we want to see how does it actually behave in an actual re-entry flow. So in a re-entry flow, what do I mean by that? I mean an airflow that goes around at 25 times the speed of sound, so about Mach 25. But it could be, say, Mach 10, Mach 15. So different velocities or speeds of the air. So in our labs, we can generate hypersonic speeds, and we can generate different speeds of airflow. Once we have these 3D printed porous materials characterized, so we understand that we can actually make it sweat, a particular gas, we would place it in the tunnel. And by tunnel, I mean hypersonic tunnels, so where we generate these hypersonic flows and see how it interacts with these re-entry flows, say air flows that go beyond Mach 10 or 15, and so on, and really understand the physics of the problem. What I want to focus here on is, okay, I have this layer of gas and I'm injecting, I'm sweating this gas, but how much do I have to sweat to protect the vehicle for a given mission, right? And that is given by how this sweated gas is mixing with the hot gas. Again, two fluids, two types of gases would want to mix. So what we are trying to find out here is, what is the fundamental mixing mechanism? And then what sort of gases should we look at? Is argon better than helium, for example? And that's for Earth's re-entry. What about if we go to Mars? The Martian atmosphere is mostly carbon dioxide. So what gas should we sweat in that case? So we don't actually know the answers to it. So this is why we want to create the re-entry conditions down here in our lab and collect data and then find the new physics out of it.
Hassan, lastly, you said, you devoted your life's work to this research. What's the dream here for you? What do you hope to see?
I will get emotional, but no. Imagine a world where you can fly anywhere within 2 hours, right? You can go to space, come back again. I mean, I'm sure that a lot of the youngsters today, they would want to wake up to a future like that. So for me, this is, the work I do here is, if we can have a future like that, why not try?
Hassan Ifti is an assistant professor at Texas A&M University. Hassan, thank you so much for joining me today.
Marianne, thank you so much for having me on your show. Thank you.
That was our producer, Marianne Summerall, speaking with Hassan Ifti, an assistant professor at Texas A&M University. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do it on the Central Florida Public Media app, the NPR app, Apple Podcasts, Spotify, really anywhere you get your podcasts. Stay connected with this show. Be sure to follow us on social media. Our handle is AWTY Space on both Instagram and Facebook. And if you've got an idea for a future episode of the show, or you think you'd be a good guest, well, reach out to us. Our email is arewethereyet@cfpublic.org. More space coverage online, cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marianne Summerall. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.